We're reaching the end of 2 days. In my opinion, there were 2 great days. I hope 50% plus 1 of you agree with me. That will be great. If it's more than that, I will be even happier. I heard some of you say good things about the program, about the variety of topics, the excellent presentations. I am happy to take the compliment. I love people who say I did a great job, but I didn't do that. I mean, and I will tell you the secret. The secret is we did a great job in picking great moderators, and then we cut them loose. We say, this is your session, you design it, you pick the speaker. We may have given some suggestions here and there. For example, this outstanding presentation of Professor Kenichi Soga. I would take the credit of suggesting it because I have seen it in the HPC, and I know you have your new peer project, and I love your comment about, and I thought I can join peer. I love that. So I have to repeat it. But really the credit go to the moderators who picked their speaker. And I think that's the best way a center should function, is you let people do the things they are good at. And if Professor Kramer is excellent in his domain, he should be the one who designed his session, not us. I'm just picking you because you are here. So. So that was the secret, and that was the idea of the steering committee. So it was also a great thing to have the annual meeting designed by a steering committee, and they again did an outstanding job. I cannot leave this without really thanking Grace Kang. She really was the dynamo behind the whole thing. Her experience in organizing this 2 years ago with whatever glitches she enlisted, I think she managed to fix them all. The work of Amarnath, he joined us less than a year ago, but he's really added a lot of energy to the center. His effort in day-to-day outreaching to our business and industry partners is great. Having that touch with the community, with the practitioners, the people who really use peer products is essential. So what else I want to say? I want to say so many things. The presentations were really outstanding. It shows breadth of things have started many years ago, a strong continuation of them, whether it is work on NGA projects or work in modeling or good experiments here and there, and also some new ideas. I am proud of the notion to use blind prediction. I heard positive things about that. I think we will do our best to have this an annual event that go into our annual meeting. I heard a lot about data and data analytics, about machine learning. I thought when I presented this thing about images and stuff we do, I was prepared to receive some rotten tomatoes thrown at me, but at the end of the day, I don't think that's the case, because it seems it's a topic of interest to people. We have lots of data. Computer scientists would really die to get access to our data and do feature engineering on it. And we have that, and we can learn quite a bit by working with them. The other thing I would like to mention is, these are all good things I said. I'm sure there are things we didn't do well. And please share with us your feedback. You can always send us an email on peer_center@berkeley.edu. Let us know what we did bad, wrong, but also let's know what we did good. You know, we also like to hear that we have done a good job. So send us email on our center email, and we will try to fix any problem in the next annual meeting. So I'm not going to take any longer. I just will invite, I will go in order of C1, C2, C3, and C4, the moderators to give their final summary of their session. I am not going to come back here, so the last presenter will be the one for C4. So I would like to wish you safe travels if you are not from nearby, and we wish to see you again. I am really impressed that every conference or whatever I attended, there is less than 20% in the last session. I would say every table has some people, so you must have liked what you see and you stuck to the end, so that's great. So the first is Professor Maley to give a short summary about C1, which has to do with buildings.
I'll be brief because we're late-ish in the day, and I think fewer words are words that are easier to remember. And so let's go in. I had the pleasure of chairing session C1, which was on buildings this afternoon, and we had in 4 presentations 5 presenters. We heard about the TBI guidelines, heard about modeling in core wall buildings, which are commonly the kind of building that is being designed by guidelines like the TBI guidelines, and heard about high strength reinforcement, and then about implications of ATC 58. Let me just spend a few minutes on each one of these, actually 1 minute on each one of these. Ron Hamburger talked about the 2017 update of the tall buildings guidelines, and in the guidelines talked about changes that occurred in terms of risk categories, in terms of modeling and procedures, most importantly in terms of acceptance criteria. And in the tall buildings guideline, there's not a direct probabilistic check using probabilistic methods on the performance of a building, nor do we use SP3 or some software of that type to check the performance, but instead there are acceptability criteria that are formulated very much like those in ASCE 7. The intent being to achieve indirectly the intended performance. And I think a great question for a peer to consider future research studies and pursuits is how well do those guidelines actually achieve the intended target performance? Wallace and Kulasvari talked about modeling of core walls, introduced some new ideas related to the use of expected strengths, new stiffness properties, some new ideas for modeling of core walls. And core walls are indeed very complicated elements, very difficult to test in the laboratory. And the modeling procedures that are commonly used in practice today are pretty simplistic. And yet these are being used for iconic buildings, ones that need to perform well in future earthquakes if we're going to have resilient cities and if we're not going to endanger blocks around a given 600-foot tall building. We need to have good performance in those buildings. Some very interesting discussion related to something was called a B factor or a bias factor, and the use of strengths that are a little different from the strengths that are specified in our building codes, the ones that go through a lot of consensus review and so forth. And in the tall buildings world, some of these really important criteria don't get as much review as do the criteria that are in our building codes. And should we spend some time in what Pier does to look at those questions about what are the acceptance criteria that are appropriate to be used. Quanxi Zhang gave a wonderful presentation, very mature and experienced-looking presentation. I was highly impressed. He works with Greg Deerline, but I can tell Quanxi is the one leading the work. But on high-strength reinforcement, it's quite an important area in tall buildings construction. There's a big push in the concrete buildings area to use higher strength reinforcement, especially in some elements like shear walls, maybe columns, but shear walls and foundation mats where there's a lot of reinforcement, where the strain demands aren't so high and where it's probably feasible to use reinforcement with a little bit lower fatigue life. Caltrans is also very interested, and I talked with Mark Mahan yesterday, and he wants to and is pushing through some projects methods for accepting higher strength reinforcement in the design of California's bridge columns. And so the methodology that was presented by Zhang and Deerline, I think, is very interesting. I think warrants additional work. Applications maybe in bridge construction would be appropriate, and extending the methodology that we use in Pier, in this case looking at fatigue life and so on. Very interesting. John Hooper, I think, should have shocked everybody out of their seats with what he said in some of his presentation, comparing steel construction versus concrete construction. Comparing what happens if you design for the minimum drift and strength limits versus whether you design for something a little bit different. One thing he didn't say is that those studies are based on relatively simplistic analytical models. It was a necessity because of the large number of structures studied by a non-academic team, but by a team funded by FEMA. Big opening for Pier to see whether some of those things are real or sufficiently accurate, a chance to make a real big impact on the community for the buildings we construct. Thank you.
I've been finding that one of the great things about peer meetings is all the folks you run into and all the various business you can get taken care of having everyone together. And of course that makes for challenges to get time to take care of your responsibilities like you're supposed to. We had I felt a very strong session in geohazards. We had 5 speakers, and so my apologies to Grace, but we went a little over time. We led off with a presentation by Christine Goulet on the NGA East project, and that was a hugely ambitious, very complex project. It was the first time many folks had been involved in a shack level 3 kind of process, and I think one of the big takeaways is be careful what you wish for, because with that comes a very large burden in terms of meeting and documentation. And I'm sure down the road folks are going to ultimately be very happy they went through all that effort. It'll pay dividends in the future, but for those involved in the project, it's like, wow, what did we get into? I think one of the big takeaways, though, from that project is what's really different, of course, about the East is that there's not many existing ground motions, so the lack of data has really highlighted the issue of epistemic uncertainty. And so there's been a tremendous amount of work developing really sophisticated statistical models to better deal with epistemic uncertainty. And I imagine that those advances are going to start working their way into some of our other projects than on the NGA West models and maybe subduction. Yusuf Bazorgnia gave a talk on NGA subduction, and just to highlight a couple of advancements or issues with that project. One of the advancements is that really for the first time they're, in addition to the normal intensity measures they're looking at, they're including Fourier amplitude spectra, which has some really nice properties. But ultimately will get turned into things engineers can deal with. I think really one of the big takeaway from that project though is the challenge of the Pacific Northwest, in that there's really only a handful or a handful and a half of existing records. They're from no magnitudes larger than 7, and all of the ground motions tend to be over-predicted by the existing or the new regional models. And so what do you do with that? And do we believe it and lower the hazard for the Pacific Northwest, or do we ignore them and potentially be conservative and essentially impose higher insurance rates on everybody? So it's really a policy decision and a challenging one. Our third talk was by Arminder Krigian, who gave a nice overview of his synthetic ground motion methodology and some comparisons against data. The models are really showing to be very robust, and really the takeaway from that is that those models really have some very nice properties for engineering application. Ability to look at distributions on pulse period and things like that are a little bit harder to do with empirical models. So really kind of fills in some gaps from some of the traditional ways that we've done things. Our fourth speaker was Steve Kramer, and Steve gave a talk looking at how you can use, if you have ground motion at sites that potentially liquefied, you can look at the change in the frequency content to make assessments about liquefaction and when it occurred, and ultimately develop a new triggering curve. And probably the takeaway on that is I challenged him to do some additional work, and he said, fine, give me the funding. And so we'll have to go back and take a look at that. And then finally, Sylvia gave a talk on just a huge number of ground motion tools that have been developed recently. And it was nice because she could kind of look at it from a high level perspective and pointed out the advantages and disadvantages of websites, which can be great for users, but really a big burden to develop the interfaces. And she pointed to really the new trend now is moving to an API world, to where we can just send requests to websites and get the data back, and we can do with that data what we want in the format we want, combine it with other things we want. It's a very flexible framework, and that's something that I think peers should readily embrace. So that's all I've got. Thanks.
I thought they were going to give you a bigger one. Bigger. Thank you.
Okay, so my session was on session C3 on bridges. We had 4 presentations. The first 2 were kind of related somewhat. It probably was motivated by the recent interest on ABC, accelerated bridge construction. So really looking at new ways to, to speed up construction. So the first talk was by Saeed Saidi from the University of Nevada, Reno. And so he was looking at both new advanced methods and materials. And I think one of the nice things he said to the grad students who are here was that we need to move from traditional steel and concrete and start looking at advanced materials. So he, I think, presented experimental tests on 2 specimens. One was a single column and the other was a 2-column bent. And in this he used so-called precast columns with pocket connections. So you can essentially, have these precast connections and kind of build them together on site fairly quickly. He used unbonded CFRP tendons for self-centering and used 2 types of new materials, a ultra high performance concrete as well as some engineered cement composites in the plastic hinge zone. And I think through these tests he was able to demonstrate a fairly significant improvement in the performance of these, what I would call, innovative systems. He also indicated that he was able to simulate the observed response of these tests using just available materials and models in OpenSeas. So again, that's another good thing for OpenSeas. So like I said, the second talk was the PI on that was Jose Restrepo, but the presentation was made by his graduate student Arpit. This was a collaborative project, and this was actually part of the the competition that they had, which Khalid presented yesterday. So again, the objectives were also related, like I said, to accelerated bridge construction, where they tested a 1/3 scale model of a 2-column bridge pier, and this represents an existing bridge in California. It was a concrete filled tube, and portions of the rebar were replaced by unbonded post-tension bars. So the presentation really focused on the design and construction details. The specimen was subjected to both horizontal and vertical ground motions. They're not commonly done. There are very few tests that have been done with both horizontal and vertical motions. In all, they applied 12 ground motions on this specimen from 8 different earthquakes with increasing intensity. I think I noticed that peak drifts exceeded about 7%. I hope that our bridges don't see these kind of drifts. But despite that, the residual drifts on this specimen was, I would say, negligible. There was no mild steel fracture and fairly mild loss of the post-tensioning force in some of these high-intensity motions. So those 2 are fairly kind of related presentations. They focus primarily on shaking table testing. The next presentation was on the effect of corrosion damage on reinforced concrete bridge columns. This is again a topic of recent interest. The PI on that was Claudia Ostertag, who could not actually join us. So her graduate student, Ian Williams, made the presentation. And so here they were looking at corrosion in the longitudinal bars in the plastic hinge region. The challenge here was, this is kind of a new project of its kind, and there's very few models out there for them to model the corrosion or any tests that really looked at corrosion in an existing specimen. So they resorted to hybrid simulation where the corrosion was done in the lab using accelerated corrosion methods, whereas the numerical model was a 2-span single-column bridge. Okay, and here again they used advanced materials, and one of the materials that was introduced in the project was a hybrid fiber reinforced concrete, which had multiple tiers of different fibers. And again, the experiments that was shown clearly indicated that these specimens with this hybrid FRC, performed a lot better than conventional concrete. The last presentation was something that I gave, which kind of summarized a workshop that we recently had on a workshop that Pierre and Caltrans co-sponsored, and this was on bridge column capacity limit states for the next generation shake-cast platform. So those of you who don't know about what shake-cast is, it combines shake map, which is what USGS puts out in the event of an earthquake, and is able to kind of simulate ground motion that was felt in neighboring sites. And so what Caltrans does is take the shake map and then use their fragility models to predict damage to the bridges in the neighboring regions. And of course, the current shake cast actually uses HAZs, which has very limited data on the types of bridges and fragility models. So a large part of this effort was trying to come up with new capacity limit states for a whole range of different bridge types, classifying failure modes and different eras of bridges, going back to pre-1970 bridges in California to some of the modern bridges. And so using this database of tests, they were able to compile a whole new set of limit states and calibrate them to damage states. So the purpose of the workshop was to gather a group of experts to look at some of these models and to provide feedback, and which is what happened at the workshop. I thought it was a successful workshop, and the feedback that Caltrans has from this workshop will help them go back and redo the survey and revise their limit states again, so it could help with the next shake-cast platform. All right, so that's a quick summary. Thank you.
Oops. There you go.
Thank you. Okay, well, I'd like to summarize the session C4, the title of which was Designing for Geohazards. It featured presentations by three researchers who have had relatively recent funding through the geotechnical program of PEER. And they dealt with, in one respect or another, soil structure interaction, one with respect to procedure for mitigating liquefaction hazards, another for lateral loads on piles and a little bit on retaining walls, and then we had a state-of-the-art review of PY analyses. So our first presentation was by Ross Boulanger of UC Davis, who talked about mitigation of ground deformations for embankments or dams that are underlain by potentially liquefiable soil. And so he modeled a situation where a dam was underlain by some liquefiable alluvial soils, and they improved it with a series of soil cement walls that you can see here that would be constructed in situ in the ground within the liquefiable soil. The idea here is not to prevent liquefaction from being initiated, but to control the deformations and to minimize the deformations to a level where the crest of the dam would not settle excessively. And so they undertook a testing program that involved centrifuge testing on the UC Davis centrifuge, where they subjected the model to different levels of shaking, a weaker level of shaking that caused none to minor cracking of the soil cement walls, and then a stronger level that caused significant and pervasive cracking of that wall. They measured the deformations, they exhumed the model afterwards and looked at the mechanisms of those deformations, and they performed a series of numerical analyses, two-dimensional analyses of this three-dimensional structure, where they used kind of weighted average smearing of the soil and soil cement properties in a 2D analysis, and were able to achieve good predictions of the deformations and the patterns of those deformations. They over-predicted the settlement a little bit, but all in all, good predictions of these results, which gives some confidence in the use of this type of a procedure for mitigating these kinds of sites. The second presentation was by Scott Brandenburg of UCLA, looking at kinematic soil structure interaction and its effects on piles and walls. He looked at the issue of kinematic ground motions or foundation input motions from the tops of pile foundations, showed us what factors would tend to affect those, and relating to the wavelengths of the motions to the stiffness of the piles. Reviewed an analytical solution that was developed for a constant shear wave velocity model, compared its predictions with measured transfer functions from actual tests, and show the extension of that model to cover more realistic conditions where you have soil layers with different velocities, and discuss the results of those types of comparisons, how these types of models can be extended to meet these more realistic conditions. Scott also talked about using these kinds of approaches and applying them to retaining walls. Our procedures for retaining walls that are most commonly used are the Mononobe-Okabe procedures. I think Mononobe's paper was written in 1926 and Okabe's in 1929. They're pseudostatic methods, and some of these soil structure interaction or kinematic procedures offer a great improvement over those, potentially great improvement over those, much more realistic and accounting for the dynamics of the problem. Ann Lemnitzer made the third presentation and described her work towards next generation PY curves. PY curves are a common analytical procedure for laterally loaded piles. She's assembled a team of academics, practitioners, and government agency representatives to look at this problem in some detail. This is the first part of the project that's been underway so far. Anna reviewed the advantages and limitations of the PY method, looked at load test data that they've compiled, 65 large-scale tests. They've also they've created a database for those that I can't remember if it's up yet or if it's about to be up, but that will be available and a great resource for people in research and in practice. And then she described a state of practice survey where surveyed a bunch of practitioners about how they did their analyses, what programs they used, what kinds of modeling techniques they used, where their sources of uncertainty were, and shared with us some of those results, which were very, very illuminating. And so it was a very nice session. I appreciate all of the speakers for making those presentations. That's my review.
Okay, we are 9 minutes early. But I'm not going to use them all. I'm going to use maybe 30 seconds so we can establish new Berkeley time that we finish almost 10 minutes early rather than starting 10 minutes late. So we had almost 50 speakers. We only reviewed the work of 16, but I would like to thank all the speakers. We didn't review their other work because it was all in the plenary session, so we all attended that. So again, for the last time, I would like to thank all of you, all the speakers, all the moderators for their hard work before the meeting and during the meeting, all the students who help with the timing to keep us on time, plus some, we save a few minutes. And I wish you all safe travels, whether it's short distance or long distance. Some of you will travel back to Italy or China or Japan. So thank you all, and see you next year or anytime sooner. Thank you.